So here's the video I made of teaching Watson how to detect when the eggs are boiling, as you saw here, right? And this is on my channel. And now I'm going to walk through the code of how I did this. All right, so how did I teach Watson about eggs? Well, what I did is I run this little command, right? So I do from the command line, while true. This is just and then it takes a photo. Every 10 seconds, it'll take a photo. So I did that, and then it created all these photos, right? So I had it hanging, and I boiled eggs, and I had it take photos every 10 seconds, and then I had a group of photos. So that looks like this. These are all my photos, right? And then I grouped them by boiling. These are the ones that I said are boiling. And then these are the ones I said not boiling. Cloud.ibm.com doesn't require a credit card or anything. This is actually the light plan, so you get like 1,000 calls per month to test this stuff out with no cost. So then I can go to catalog, go to the AI, or you can search. And I'll go to visual recognition. You see light, which means it doesn't require any funding to experiment with it. So it does custom model, food model, general model, and these will tell you general purpose images, like it'll tell me that it's an egg. What it won't tell me is that it's a boiling egg. That you need to customize. So I could do create, but since I already have one, I'm going to use the one I already have. I go to my services, and I'm going to go to my visual recognition, which matches the other videos I've shown on setting up Watson. This is your API key when you create it, and then you do create a custom model because we're going to train it on boiled eggs versus not boiled eggs. So I've already done this, but I'm going to create it here, and it'll jump me over to the Watson Studio development tool. Development, somewhat of a misnomer. You don't have to be a developer, just a person that can group a bunch of photos and say this is boiling and this is not. That's effectively what I've done here. That's the training. And behind the scenes, there's NeuroNet that backs it, but you don't have to do all that. So you would create a new model, right? And then specify what you want, custom model, right? Which I've already done. So I'm going to go back, cancel this one, and choose my custom model here. Edit it. And you'll see that I created two classes, boiling and not boiling. You click here and then name it. I said boiling. That's effectively what I did. And then I browsed and found all of these eggs. I took these eggs in boiling, put them in a boiling folder, zipped it up. Created another folder for not boiling, zip those up, and then you just specify that. And then that will upload it here, as you see here, the zip. Then I label this as boiling, then I just drag boiling onto there. And for not boiling, I drag that onto not boiling, right? And then I say train, and it takes about 5 to 10 minutes. Now, once it's finished training, you can click trained, and here's your ID that you'll use for calling it, and then I say test it out, and so now you can grab an image, for example. Now when you're testing it out, you want to make sure that you're testing it against images that are not in the training set. In other words, if I use images in here, well then of course that's going to work because it trained on that. What you want is an image it hasn't trained on, because that's what's going to happen when you try to boil in when you're making eggs the next day. You know, these bubbles, the water configuration, that's all going to be different with every photo that it takes. So see, 81% that's boiling. Now I take one like this. It says not boiling, right? So that's what we want to produce from the Raspberry Pi. So how do I do that? Well, now I've trained it, this model's ready, and now I can invoke it. And this tells me how to call it. right here. I want to classify an image, right? So let's look at how I do that. So over here in my command line, I created a little script called monitor eggs. Right? So what it does is use your visual recognition key. This is a custom model. If you want to see that, let me find that for you. Here it is. Here's your API key. You go to your visual recognition service, your instance, and get that key. That's what you enter right here. Right? Now I need a custom model. That is my custom model here. Right? Okay, and then you just use whatever field you want here for the name of your file, so your image. So this Raspberry still is a Raspberry Pi command. You can install it with apt-get and then output it to this file. Sleep for 5 seconds because the photo takes a few seconds to capture. Then I use this command here. Now I don't want to do a URL. I actually want to do a specific image. So that matches this approach here, image file. Right? So that's where I get this @ sign and the file name, which is here. Then I tell it the classifier IDs. This is all in the API for the curl. I'll show you how to do that. Yeah, classify images, right? So it tells you here in the API guide, you want classifier IDs. That's what I'm using here, classifier IDs. And then I specify that custom model argument, which is right here. And then I use the default version 2018. And then the output of that, I pass it to a new file called eggclassifier.json, or I'm actually overwriting that. So let's look at what that file looks like. So here's that file. So Watson Visual Recognition with custom model will return all of this as a JSON document. All right, so what I want to do is parse out and get that. I want to know either it's boiling or not boiling. So what I do is I concatenate this file to standard out, pipe it through JQ, which is a JSON parser. Right, here's the information on that. You can download it with apt-get install, and then here's the syntax for it, which I've already done here. Specify images, blah blah blah. And then as you saw in my output, you see it's got the quote. So I use tr, which is pipe it to tr, another Unix command, -d for delete. That's a single quote, a double quote, and single quote. So delete the double quotes, leaving just the word boiling. And then I echo that out. And I set that value to an argument or a parameter variable called egg state. Then I check it here. If that matches true, then I use the aplay command, which is a Linux command or Raspberry Pi command to play audio. This is the specific audio USB driver that the USB sound card. Now you can use aplay-l and it'll give you the list of sound cards that you have if you had a different sound card. Mine is plug HW00, and then it plays eggs are ready or it plays eggs not ready. Now how did I get this file? Eggs ready, eggs not ready. And that's all it does, right? So let's look at how I got that. I cat my collect images. You'll see I do it right here. So the XX is obviously redacted so that you don't see it, but if you came over to your speech to text to speech, I pass in text. The text is, sir, your eggs are ready, right? I call this API, tells me right here how to do it, passing in my username and password. And then I tell it to synthesize that, and it's gonna output a WAV file, right? Just like that. Well, that's what I'm doing here. And I say, in this case, I want to use female voice Allison. And that creates a file. So that's what I call when the eggs are ready. So there you have it. Watson learning how to help tell you when your eggs are boiling and when they're not, so you can go have the perfect egg. So thanks for watching, and if you like these videos, then subscribe to my channel and I'll continue to make more. Have a good day.